Welcome back. Today is day 4 of our triangle relationships unit. First, we will use GeoGebra to explore exterior angles of triangles. Then we will prove the exterior angle theorem. Hope you enjoy the video. We need to cover right now. So we're going to be talking about some exterior angles of a triangle today. And let me show you. So basically, the interior ones are the ones on the inside. So we have 3 interior angles, A, B, and C. All right, but if you extend out one side of your triangle, like this one here, you create another angle out here, and these are called your exterior angles. So when we extend out one side, we create some exterior angles. So I extend over here, I create another exterior angle, and if I extend over here, and you can do it in other directions too, but these are the angles that we're talking about. So when we say exterior angles of a triangle, that's what we're talking about. But now there's some other terms we need to know. We have something called remote interior angles. So let's see what we mean by remote. So remote definition, just from the internet. Remote, separated by an interval or space greater than usual. So separated by some space greater than usual. All right. Far removed in space, time, or relation. So far removed in space. That one would probably be good. Example, a remote cabin in the hills. So there's some cabin far away in the hills. All right. We also have one that's very relevant right now, remote learning, right? We're learning, we're not at school right now. We're learning remotely, some big distance between us. All right. So anyways, so in this problem, it says the remote interior angles of F. So we have F over here. Here's F. Now, there's going to be 2 of them. Where are the remote interior angles? So there's 3 interior angles, but which ones are the remote ones? Which ones are the ones in greater distance? Well, in this problem, that would be B and that would be C. All right, so B and C are going to be the answers for F. All right, so it's not too bad. So B and C. Let's try it for D. So for D, which ones are the remote interior angles? Well, the ones at great distance, the inside angles that are great distance away. Well, it's not C, it's going to be the other 2. It's going to be A and B. All right, and for E, the remote interior angles are going to be the 2 that are some great distance away from it. So that would be A and C. All right, so these are what we call remote interior angles. Okay, so they're going to be some great distance away from the angle that we're talking about. All right, so let's do some problems. This applet is supposed to say here. So exterior angle theorem. Use the slider to rotate the triangle 180 degrees. Now use the red point below to translate the triangle. Okay, so look what we see here. I see a triangle and I see 3 angles. I see the interior angles of the triangle, the green angle, the purple angle, and the red angle. And then I see the little space for an exterior angle. So they created an exterior angle. So we're going to learn a relationship right now just by looking at this picture. So let's see what we learn. First thing I'm going to do is I'm going to rotate. So I'm just grabbing this slider and I'm rotating. So you see how it's rotating right there, and it lands right there. Oh, interesting. So it lands in that little spot right there on my exterior angle. And then I'm going to grab this little red dot and I'm going to drag this little dot. So I'm going to drag this dot over, and what do you notice? Bam. Oh, passed it right there. Oh, passed it again. Right there. So what do I notice right now? So that spot for the exterior angle, so remember there was a spot for the exterior angle. Let me put it back. So that exterior angle right there is now filled in with what? A purple and a green angle. So the exterior angle is now filled in with that purple and green angle. So what can we conclude here? What's our conclusion? Well, it looks like in this example that an exterior angle is equal to whatever the purple and the green angle is. And now I wonder if this always works. Well, this is really cool because we can drag this triangle around And what we notice is still fills in there. So no matter what happens, no matter where I place this, look at the green angle is getting really small. Green angle is getting bigger. Purple one's getting smaller. All right, so no matter where I place this, that extra angle looks like it's equal to the sum of the purple angle and the green angle. They filled in perfectly. All right, perfect. So what we're gonna do is we're gonna actually try to prove that now. Well, let's try to prove that. Let's try to prove that the extra angle is equal to the sum of those, and those are called remote interior. The interior angles that are far away, so the remote compared to the extra angle. All right, first thing we're gonna need to do, let's number some angles. That'll make our life a lot easier. So let's call this angle 1, this angle 2, this angle 3, and this is angle 4. All right, what are we given? I don't know, we're given triangle ABC. We're not really given much here. All right, so we have a triangle. What are we trying to prove? Well, we are trying to prove that the measure of angle 4, so the exterior angle, is equal to the measure of angle 1 plus the measure of angle 2. So we were trying to show, like in the GeoGebra applet, that the exterior angle is equal to, remember, so this exterior angle right here is made up, this angle is made up by the angle here and this angle here. So we're trying to show that 4 is equal to 1 plus 2. So let's see if we can do that. I'm just going to get rid of those for a second, and let's see what we got here. So now we have a proof here. It looks like, it looks kind of easy. It looks like we have 4 statements that we're going to have to write. What do we know about this picture? Well, I see a triangle there, and what can you tell me about angle 1, 2, and angle 3? Well, I know the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180. And how do we know that? Remember, we have to state our reasons. How do we know that 1 plus 2 plus 3 is equal to 180? Well, they're triangles, and we proved this actually. So this is our triangle sum theorem. Perfect. Our triangle sum theorem says that all triangles need to add up to 180. So there we go. Angle 1 plus angle 2 plus angle 3 is equal to 180. All right, also, what else do we know? Well, we should remember from a long time ago, these angles 3 and 4 are called a linear pair. So I'm going to say for this one, the linear pair postulate. And if you just told me like definition of linear pairs or something like that, I'd be cool with that too. But what do we know about angle 3 and 4? Well, we know that the measure of angle 3 plus the measure of angle 4 has to equal 180 also. Perfect. So check that out. Two things that we've been building on for a while. We know triangles add up to 180. We know linear pairs add up to 180. But now, what's very interesting about this? What is very interesting about this problem? Well, both of those statements say something is equal to 180. Well, now we can just do a little either substitution or transitive property, however you want to do it. Let's do a little transitive property. And we can rewrite that statement without the 180. So in this case, I'm going to say, you know what? The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. How do we know that? How do we know that 1, 2, and 3 has to equal 3 and 4? Well, obviously, they're both equal to 180. So if they both equal 180, they must equal each other. All right, so now take a look at this. Now we've said, well, triangles equal 180. We know that the linear pair equals 180. And what you should see here is in this statement, you have a measure of angle 3 in both parts of your equation. All right, on the left side and the right side. So let's wrap this up. Let's just use a subtraction property. Subtraction property of equality. All right, so what we're going to do is subtract the measure of angle 3 from both sides. So we're going to subtract that from both sides. These will end up canceling out, so these will cancel out. And what will you be left with? And you'll see right now, measure of angle 1 plus the measure of angle 2. No, I can't write. It's not letting me write. Angle 2 is equal to the measure of angle 4. And guess what? We have done it. We have just proven to ourselves right now that no matter what happens, look at that's with no numbers. No matter what happens every time, angle 4 is the same thing as 1 plus angle 2. Just adding those up. So let's write our theorem. So what is our exterior angle theorem going to say? Exterior angle theorem. The sum of the remote. Let's not write it that way. I don't like that. Let's write it a little different. The exterior angle of a triangle is equal to the sum of the remote interior angles. And we're done. So from now on, look at, we're just keep adding more and more rules, more and more definitions, or more facts to our understanding of triangles. So now forever, when we see a triangle and we see an exterior angle, we should know, guess what? That angle is equal to the sum of the two remote interior angles. Game over. Let's see if you understood what you learned today. So it says find the measure of each indicated angle. So we want to know, what is this angle right here? What's the measure of that angle? Well, guess what? That's an exterior angle. And if that's an exterior angle, then that angle is equal to this angle plus this angle. These two angles added up. So guess what? What we know right now, this angle is equal to 80 plus 60, which is 140 degrees. Look how fast that is. That's very nice and simple. The exterior angle is equal to the sum of those. That's what we just proved. So let's try it again. So we want to know this angle here. So you want to find out what the exterior angle is? Well, guess what? You can find that by just adding up the two interior angles, the remote interior. Remember, they have to be far away, not the one next to you. All right, so we're going to find this angle by just doing, well, this is equal to 78 plus 50, which is 128 degrees. Perfect. So simple. So guess what? Here's another here's another exterior angle. So this exterior angle is equal to the sum of these two angles. That's it. That's all you have to do. So this angle, so you're saying I just have to add these up? Yes, that's all you have to do. So those angles is equal to 70 plus 45, which is 115 degrees. Game over. All right, so let's go. Let's wrap this up. Last problem. All right, so here we go. Solve for x. It looks like we have a triangle. We have two interior angles, or remote. We have an exterior angle. So guess what? What do we know? We know that this exterior angle is equal to the sum of these two angles. So these two angles added together have to equal my exterior angle. So I can write myself an equation. So 18x plus 2 has to equal what? What does that have to equal? Well, that has to equal 8x plus 8 plus 64. There we go. So there's my equation. So now if I solve that equation, and I'm going to use GeoGebra to solve that, so I'll show you that in a second, but I've already done that. So my answer is, guess what? X is equal to 7. And there we go. So remember, this is nice and simple. This is my exterior angle. So this blue angle is the exterior angle. And that has to equal what? The sum of these both are my interior angles. So this is interior angle 1 plus interior angle 2. So those two angles, so here's one of them and here's the other one. That's it. So simple. And then I just use GeoGebra to solve this real quick. So that's going to be x equals 7. All right, hope you enjoy this.